Hey y'all, we've made it to the final lesson on new content for the year, and we're going to talk about solid figures now, the surface area and volume, and how they're related when we have similar solid figures. So if we have two solids and they're the same shape, so they're a prism, or they're both cylinders, or they're both cones, or pyramids, or spheres, then all the corresponding parts are proportional. It's kind of like when we did similar triangles. The corresponding sides were proportional, meaning that if we wrote a ratio of the sides, those fractions would be equal. So if we look at these two similar prisms, those are the two small sides. Those are the two big sides. And then we have the other ones in the middle. So those are the corresponding sides. So since they're similar, then we can write a proportion. I did the little solid over the big solid. So we have the yellow ones, the green ones, and the blue ones. And if we simplify those fractions, we get 3 over 10 for each of them, and that's what we call the scale factor. So if we have two similar solids and we have the surface areas, the ratio of the surface areas is the scale factor squared. If we have the ratio of volumes, it's the scale factor cubed. So I'll type that in here, scale factor squared. Scale factor cubed. So in this example, we have surface areas for these two cylinders. So if we write the ratio, I did the small one over the large one. And first of all, just as a note here, these pi's will cancel out. If I take the square root of 7 and the square root of 175, or the square root of 7 over 175, I can get the scale factor, which in this case is 0.2. So again, if I have the ratio of surface areas, if I write the fraction of the surface areas and I take the square root of that fraction, I'll get the scale factor that relates the two similar cylinders. Similarly, if I have the two volumes, volume is the scale factor cubed, so to the third power. So I take the cube root, notice the 3 here, I take the cube root of that ratio of volumes, and I get the scale factor to be 0.3 repeating, which is the same as 1 over 3. So there's my scale factor. So pause here and find the scale factor for the left one given the surface areas and the right one given the volumes. So I start by writing the ratio of the surface areas. I always do small over large. I take the square root of that ratio, square root of 275 over 396, and I get 0.83. For the volumes, I'm going to take the cube root of that fraction, so the cube root of the two volumes, and again, I'm doing small over large, and we get a scale factor of 0.8. So we can use that information here, and if we have a surface area and volume of one similar solid, and then we have, for in this example, the surface area of one, and we want to know the volume, we can write the ratio of surface areas, since we know them, And right now we're going to just try and find the scale factor just like we did in the last one. So we will square root those surface areas and find the scale factor to be 0.6 repeating. Then we want to know what the ratio of volumes is, so we can set that equal to the actual ratio of volumes. So the ratio of volumes is the scale factor cubed. So we're just going to cube 0.667 and get 0.296. 0.296 represents what the ratio of volumes should be. So if I wrote question mark over 810, it should be equal to 0.296. And then we can solve that for question mark and find that the volume of the smaller solid is 239.76 inches cubed. And it's smaller than the large one, which makes sense. I want to do an example here where we have the volumes and we're looking for a surface area. So I write the ratio of volumes. And then I'm going to cube root that ratio so I can get the scale factor, which is 0.6. Since I need to write a ratio of surface areas, I'm going to square the scale factor. 0.6 squared is 0.36. And then I can write an equation. The ratio of surface areas, 63 over question mark. Since I've been doing small over large, that's what I need to continue doing. I'll solve for question mark, and I get that the small surface area is 175 inches squared. And we wanted it to be bigger since that's the bigger figure, so it makes sense. So pause here. I've given you two surface areas, which is like the first example I did for these. Find the big volume, the big volume. So we'll start by finding the scale factor. We write a ratio of surface areas and get the scale factor to be 0.625. We need to write a ratio of volumes, so we need to cube the scale factor, which is 0.244. We can set up an equation. The ratio of volumes, 0.244, is actually equal to little volume. Oh, I did big volume over little volume. No, I didn't. I'm sorry. I did little volume over big volume. I solved for question mark, and I got that the volume we're looking for is 3,248.128 inches cubed. And again, I was looking for the small volume, and that's smaller than this one over here, so that makes sense. Remember, volume is cubed. So I have two you-dos for you to do. In this first one, I want you to find the scale factor. Find the scale factor from the small one over the large one. And in this one, I want you to find the surface area. This is the surface area of the smaller figure. So try those two. I'll answer questions in class, and we can do some practice.